Good morning. Today I'm going to be working on a binary file format reader. I'm going to start out with the binary file format, and then I'm going to move on, if there's time, to working on a front end and YT for it. The file format specifically is called Phantom. It's an SPH file format, and what I'm going to do actually is I'm going to save their documentation, and then I am going to open the documentation inside my terminal, and that way we should be able to see it a little bit better. Anyhow, and it'll be less distracting with the lights changing. So I'm going to start out now. Oh, no, here, let me move myself over here. I'm going to start out by doing it in KaiTai struct. Okay, so the Phantom file format is, I want to say a couple things about this first. The Phantom documentation is awesome. It's not just really nicely written, but the extent to which they discuss things like, here's how here's some resources for programming in Fortran. There are resources for how to use VS Code. There are resources that describe the various different coding and philosopher guidelines. Like it's really friendly done. I have a lot of respect for taking this much time to write out not just what to do, but why to do it, and I'm genuinely quite impressed. It's very nice. So I just have a ton of respect for the folks that work on Phantom, and I should call them out by name, but I don't want to miss anyone. So the code paper, its first author is Dan Price, but it's just very impressive, and it's good to see. So, all right, I'll be listening to my favorite Beck album, Midnight Vultures, while I do this. So I'm going to open the source file here, and it makes some really good points about why you may not want to do this, but I'm going to write a binary file format reader for it. So they have some clever bits in here about coming up with an opening gambit. So what I'm going to do is I've actually started with an old Ramses reader because there are bits of the metadata that I always have a hard time recreating in KaiTai struct, but I'm going to develop a KaiTai struct reader for it before I move on further. So, very first line consists of magic numbers designed for sanity checking. So what we're going to do is we're going to have this opening gambit ID, because that's what they call it in there. And it's going to be a sequence. And the very first thing I'm going to try doing is let's see, size 4. And I'm just going to put all this stuff in here. So I1, R1, I2, iVersion, I3, and that should be the end. I1, I2, and I3 have specific things that they are equal to. This is cool. It's a way that they make sure that you've read the exact right number. And so we'll call this header I1, contents 60769, type, and now this is the default integer kind. So KaiTai doesn't necessarily have a concept of a default integer, so I'm going to call this I4, and we're going to have little endian, and let's see how that comes out. First things first, let me make my window like this, and we're going to take this step by step. We're going to load this up, KSV. The first item that KSV takes is the path to the binary file. And the second thing that it takes is the KSY file, and it might error out. let's take a look. Value outside of byte range. All right, well, let's give this a shot. Python 3 hex 60769. ED61. So let's see if that works. Nope. Expected that, but got 0000. Oh, that's interesting. So let's give this a shot. Here instead, we'll say size 2. We'll comment that out. Let's take a look at what's actually in there. So in my opening gambit, I've got these 4, and then I've got 2, and then I've got ED61. So what that looks to me like is we actually have the correct items, but they're prefixed by 2 because it's actually a 4-byte integer. So let's try this. Validation failed, not equal to expected blah 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 blah. Oops. I wonder what that would do. That might also fail. Here, let's try type I4. Yeah, all right. All right, so that validated correctly. ID1. I'm not sure what ID1, or what this, the 4-byte tag. Oh, right. That's just the size of bytes. Okay, so here what we'll do is we'll actually, you know what, we'll eventually get this to so we will eventually be able to set up conditionals here, because the value of ID1 will tell us the size of I1. R1, okay, so now header R1, this one should be the same thing, that is equal to I2, which is equal to that. We'll call this real number in type F4. So we might end up doing some validation a little bit later. Let's see. We'll come back to that in just a minute, because we've got ID2, header I2, contents. This one, the default real kind, yeah, so that's F4, I think. Successful reads of these numbers. Okay, I2. Looks like EDCE. That's actually slightly different, huh? Yeah, this is getting a little bit different here. Oh, right, of course. Content 0, 0, 0, 0x 0, 0, 0x ED, 0x CE, which should be that. Let's just make sure of that, though. Yeah, CE. Okay. So we run this, doesn't quite validate. Oh, F8. Okay, that validates correctly. Alright, so it's big endian. I might end up changing the R, or changing the endianness somewhere else. So, okay. Next up is iversion, ID iversion. Type. That looks like it's U4. Yep, iversion U4. Now I3, ID, header, I3, contents, 0x00, 0x00, 0x. Let's see, what's the hex of 690706? A8. Oh, no. Yeah, alright, well, it's going to be a little bit different. This is going to show that I mess this stuff up all the time. Let's see, I think that's wrong. I think I got my endianness wrong or something. No, I guess not. Okay. Okay, so back to this. Oops, looks like my camera messed up again. What? Alright, let's see. I don't know why it does this. I wish I knew. But it seems like I have to refresh it every so often. It's hard to debug that too. Okay. Alright, so we've got the opening gambit header. And now I don't actually think we'll call that Fortran header, and we'll call this one Fortran footer, size 4. And actually this should be type U4. Yeah. Okay, so ultimately, and I'm going to put this in as a comment. Ultimately, if this is 24, 0x18, we know the size of the default real int is 8. No, is. Ultimately, with this header, we know the size. There we go. All right, so we've got our values. The second line now. All right, and it looks like it is not actually null terminated. So now we've got after the header, we have ID. Phantom file name. This will be a sequence. ID Fortran header again. Type U4. ID file name. No, we'll just call this value. Size type str. Encoding. I think it's ASCII. Size 100. And then ID Fortran footer. Type U4. So this will be an ID of file name. Type phantom file name. And there we go. So it looks like 0x20 is the fill-in value at the end. So I wonder what that means. First letter indicates if it's a full dump or small dump. Tagged format. All right, well, I guess then we may have to parse this. But we may not end up doing that right now. Okay, so we've got these predefined data types. Oh, neat. All right, so we'll call this data type header. No, we'll call it global header. Sequence, we'll make it empty for now. Data type header instead now. There will be 8 of these, one for each data type. each data type header is going to have okay. So for the data type header, we've got sequence ID Fortran header 1, nvars. We'll just try to type u4 ID nvars. Type, let's see, nvars 4-byte integer u4 ID nvars Fortran footer type u4. Okay, so that's a data type header there. Now the next thing we have is 1 to nvars of tags. It's an array of strings. Each tag is 16 characters in length. Tags Fortran header type u4 ID tags type str size 16 encoding ASCII repeat expression is equal to nvars. All right, and then we've got our tags Fortran footer. Okay, and now we have one more thing, which is the values. It's an array of variables of the specified type. Let's see. Now that one, I'm not so sure what it's going to look like. So, ID. Type info, repeat expression, 8 type, data type header. Okay, so now this one is a little confusing to me. Alright, so we've got ID, vals, Fortran header. Now this one, type u4, I'm going to do something a little different here. What I'm going to do is this iterates up to nvals, but nvals is not specified, is it? It's not specified anywhere else. So instead we'll use our header information here, ID vals, size vals Fortran header. And then we'll have Fortran footer. Okay. So that should be enough now to get to the next step. So let's take a look at, oh, right, of course. Opening gambit, yep, that stuff works. Here, we've now got, following the opening gambit, we've got our global header. ID header. Type global header. Yeah, that didn't work. So type info. Okay, that's interesting. Each one of these, okay, cool. All right, so these are the different headers. Now it said that it would repeat 8 times, but it looks like on the 7th one it breaks. No, it doesn't break on the 7th one. It breaks before that. So I must have missed something. Does it break on the 2nd one? No. Okay, the global header is a simple loop over the 8 predefined data types. So it should be able to have 0 values. Yeah, it's on that second one that it breaks. Is it just not? What am I reading wrong here? Okay, 168. All right, that makes sense. All right, so now this next one, the Fortran. nvars 0. Okay, I'm doing something wrong here because nvars 0 it's not reading the same number of at the start and at the end. Why is it not reading the same number at the start and the end? It's because, let's see. It takes 1 to nvals. I think that must be a typo for nvars. Oh, I see why. I think. No. Yeah, why is this 2 here? It says that it's writing 4 bytes. So it should be properly Fortran header 4 nvars equal to 0. Then it tags. Maybe it always writes something. Yeah, because the footer here, the footer and the header should always be equal. So max nvars 1. Can I do a max? Let me see. Kaitai struct min max. All right. So nvars equals 0. If that's true, 1 else nvars. Okay, oh, right, okay. Repeat expression nvars. And then this is only included if nvars greater than 0. If it's not greater than 0, id empty. Type size 4 if nvars equals 0. All right, let's try that. That doesn't seem good. Seems like it's having some trouble there. All right, so what's going on here? If nvars equals 0, let me just repeat the expression up to 3. Okay, should be able to manage 2. So empty, all right. Okay, now the header. Now, there's got to be something wrong here. I'm doing something wrong. There's no possible way this is right. So, because look at this, I external. Yeah, it's not getting the tags right. There's some other problem going on here. So let's take a look here. So it's getting, so this is my 4 bytes, nvars equals 42, and as previously shown, that's 4 bytes per 42. Out of control. So it finishes reading. Oh, you know what? I bet. If there's nothing, if nvars is equal to 0, then it doesn't do anything. So we'll make another data type here. ID var info. Data type var info. And now we'll do this as data type var info sequence if nvar is greater than 0. Okay. And then it's not gonna, that's not gonna be a problem. I think it might be easier to do parent. Okay, so, all right, yeah, of course, because if it's equal to 0, why would it write out those records? So let's set this to 8. Let's see if we can read it all now. This is a nice, elegant data format. I've dealt with a lot of these, and I don't usually like them, but I do like this one. All right, so we've got a whole bunch of information here. No variables of that type. No variables of that type. 2 variables of that type. Okay, this is looking good. 30 variables here. Here are all the types. Okay. All right, this is nice. So we've got phantom SPH. Now, following the global header is a series of array blocks. This is nice. Each is defined. Typically, a block would contain a set of arrays for a subset of the particles. Yeah, makes sense. So following the file header, we get the number of blocks. ID block info. Type, let's see, it's type block info, but where's nums? Oh, interesting. All right, 8 predefined data types. Okay. Sunset, drinking for the dreamers are 100 miles behind. Okay, now I'll call the instance info type block header. All right, ID blocks, n blocks, Fortran header type U4. Now n blocks type I think I want to do a type switch here. Do I? I mean, I'm not doing it anywhere else, so I guess we'll just say this is U4, but type switch on n blocks Fortran header. Let's see, did I do that right? Yeah, I did. Cases. Arkansas. This will be a U4. That'll be a U8. Now n blocks Fortran footer. Now for each one, block def. We'll call this blocks type block defs. Type here is U4 again. I think that, I don't know that that's all necessary, but block defs. Repeat expression, n blocks. So inside each block def, we've got a sequence of ID block def header type U4 ID. N is the integer containing the array length for each block, and then a 4-byte integer specifying the number of arrays of each of the 8 predefined data types that are written in that block. All right, so N type U8 ID nums, and then so this will have that, and there will be block type specs so now that type will be a sequence of, for each block, so ID count, let's say, type U4 specifically, repeat expr, repeat expr, repeat expression is parent dot n. And now let's see, we should be able to get that. that's not looking good. Seems like maybe it's overreading. So, okay. Did something wrong. So let's do this. N blocks 4 bytes. So the block def header, all right, now you know what I'm going to do is I'm going to copy this. I'm going to grab that. Block type spec. No, I don't have that. In my way. All right, N blocks Fortran header 4. It writes 2 blocks. The first block. The block def header. Okay, so what am I doing wrong? Did I forget a footer? N blocks Fortran footer. So blocks, block def, block type spec. I think I must have. Block def header. Then ID N. Ooh. It's breaking. Well, I'll have to come back to that in just a moment. Gotta take care of something here. Alrighty. Okay, so I've got my block type spec. Oh, you know what? Where do I read N? N blocks. And then this reads block def. So here, let me just grab this and cancel that out. So block info. N blocks 2, Fortran footer. Okay, and now the next element. NI. Okay, so that's number in I, where I is the data type. No, I is the number of blocks. So that should be 2 here. All right, you know what I'm going to try out? Sometimes it helps to do this Kaitai editor. So let's do this. We'll upload data phantom disk. Yep. Yep, uploaded just fine. Now let's make a new phantom. Okay. Duplicated mapping key in phantom. All right. So what I'm going to do here is we are going to take our block definition, because I think it's crashing at this point. Let's take a look here. I'm going to make this a little bit bigger. The block definition looks like it might now be trying to do something, so that's not good. It's probably crashing my stream too. So, yeah, right now what I'm working on is not exactly reverse engineering a binary file format, but implementing a binary file format so that I understand it and then converting that into Python. Oh, and you know what? Maybe maybe the issue here is IDN. If it has 0, if n greater than 0, will that do it? Maybe not. Good to see you, Cryogi. Loop I equals 1 to n blocks. Well, to be honest, most of the rest of the code we use is Python and Cython, and becoming basically when writing a reader like this, I become familiar with the data file format, some of its peculiarities and foibles. Well, not many foibles in this case. It's pretty nice. And then I build out the Python code to get it into our analysis tools. But I really need to understand the format before doing that, and this is one of the ways I do that. So where I'm at now is everything seems to crash, or it doesn't crash. It actually just continues reading. And I think it must be because of a repeat expression somewhere. So parent n, block type spec. So let me try this. So that's weird. Okay, so this is interesting. The number of entries is that there are 17 of this data type. Oh no, this works out. The footer is equal to the header. block type spec. Wait. Where'd that 5 come from? N equals 5. So that N is the number of blocks, and then this should sum up to the total number of elements, I think. It's a good song. Okay, so n blocks. Got the 4 bytes. N blocks. All right. Then we've got, for each block, we've got a repeat expression of n blocks. And that's a block def. Now the block def has the header, that's 4 bytes. It's got the n for that block. That's this. And then the block type spec. Repeat expression 8. That's the problem. I don't actually need that. This is type U4. Okay. So block info. Okay. All right, so I don't understand that. But I guess we'll come back to that. The array length for each block. I guess the number of arrays of each of the 8 predefined data types written in each block. Okay, I guess I can see why that would be different. Yeah. Okay, so now I guess we do our arrays. And I'm gonna have to hop off in, I don't know, 10 minutes or so. So I guess alright, this is actually pretty straightforward. Array. Let's see, block array, we'll call it. We'll give this one a params, ID, item size, and then we will say type for, then the second param will be count. We'll call that U8 just in case. And now sequence, it's going to be ID tag header type U4 ID tag type string, size 16, encoding ASCII, ID tag footer, type U4. Okay, and now we've got 4 bytes, then the actual array. We're not going to parse the array in here. ID is going to be array header, type U4, and actually, you know what? We don't even need the item size because it's all in there. ID array size array header, ID array footer, type U4. So that's 1 to n blocks. So blocks, type block def, ID arrays, type block array, repeat expr, repeat expr, and blocks. But there's a little bit more than that here because this is 1 to n of I. So So each one of these arrays type block array and we might need to get the expression. Because it's a double loop. So we need to be able to query block definition. So we need to be able to query the block definition nums for each one of these. Actually, no, I don't, because I'm reading it based on this, I think. I guess we'll find out. Nope, unable to find block array per type. Oh, right. Go drive into the farthest star. All right, let's see if that gets us to the end. It does not. In fact, it should get me to another tag right away, but it doesn't. Okay, but this is pretty far along. I need to reorganize my data types a bit, but I think basically if I can get this to query the array items, I should be able to understand it. Okay. Well, thanks for joining. Let me say goodbye. I'm going to continue this later, but maybe not on stream. Have a good one, everybody, and thanks for stopping by, Cryogi.